Hello everyone, this is Mr. Kaviani, and by the end of this video you should be able to solve problems involving connected objects that have both translational and rotational motion. We're going to revisit pulleys and connected masses as we saw before, but this time we're going to consider the pulleys as having mass, and so things are going to be a little bit different because of that. We know that when the pulley is spinning, the mass falls. This is very similar, by the way, to the lab that we did with the rotational inertia demonstrators, the spinning metal wheels. We know that as the wheel spun, the hanging mass fell. And we know that because they're connected, right, there's a relationship between the angular motion of the wheel and the linear motion of the mass. What we saw before is that once the wheel rotates one entire time, right, the mass has fallen by one circumference of the wheel, essentially. And so this is exactly the same situation as when we have an object that's just rolling on the ground, except there are two objects connected here. So because the pulley and mass are connected, we can actually use the linear bridge equations to relate the motion of the pulley to the motion of the mass. So in other words, we can relate the angular acceleration of the pulley to the linear acceleration of the wheel like this. So the linear acceleration of the mass will be equal to, right, the radius of the pulley multiplied by the angular acceleration of the pulley. This is the same equation we used before. We can relate the linear displacement of the mass, delta x, or in other words, how far it falls, with the angular displacement of the pulley, or how much the pulley has rotated. So delta x would be equal to r of the pulley multiplied by the angular displacement of the pulley. And finally, the linear velocity of the mass as it's falling can be related to the angular velocity of the pulley, again, by the same form of the equation. And so at any moment in time, we can calculate the acceleration, displacement, or velocity of one of these objects as long as we know the related variable for the other object. And so if I ask you for the acceleration of the system, essentially, we can solve for the acceleration of the pulley or the mass, and then we can find the other one, essentially. And so there's a relationship between these two objects that will be very important when we solve problems moving forward.